Number 15, honeybee hives consist mainly of hexagonal, six-sided units called cells, in which queens lay eggs. Hexagonal cells for eggs that develop into non-reproductive workers are smaller than those for eggs that develop into reproductive drones, though the size difference varies by species. Difference in cell size results in a construction problem. It's hard to neatly connect sections of small cells to sections of large cells. That worsens as the difference increases. To fill in gaps between the sections when building a hive, bees rely on cells that have more or fewer than 6 sides. A student studying beehive structure consults data on 3 species, concluding that blank. So we want to see what this study tells us about this phenomenon of sides, of cells of sides other than 6 in different honeybee species nests. So we'll take a little peek at the figure here because it doesn't look too complicated. We see in the title, it's the percentage of non-hexagonal cells in the hives of 3 honeybee species. We see on the y-axis the average percentage of the non-hexagonal cells by shape. And we see the 3 species in the bottom. And in our key, we see the 3 different types of cells, 5, 7, and 8-sided cells. And just at first glance, it looks like, regardless of what the difference is between the bars themselves, it looks like the Western honeybee is pretty significantly different than these guys. But let's go to the choices and see what we have and see what would kind of fit in with this setup here, right? We're trying to draw a conclusion based on this data and based on the setup. Let's look at A. Cells for worker eggs are probably closer in size to cells for drone eggs in the hives of the Western honeybee than in the hives of the dwarf honeybee and the black dwarf honeybee. So I like, right out of the gate, this is drawing a distinction between what's going on for this species versus these two, because the data in this figure clearly show a significant difference just in the values of these average percentages for this species than these. We just have to justify why this would make sense. Now, when we go back to the text, right, it said hexagonal cells for eggs that develop into non-reproductive workers are smaller than those for eggs that develop into reproductive drones. And then it says later, this difference in the size, which causes this variation, worsens as the difference increases. So the larger the difference in these cell sizes between reproductive and non-reproductive, between, say, workers and drones, the more you need to fix it, right? The more of the other cells you would need to account for the size difference. And so since there's not many of these random cells here, compared to these other species, we especially focus again on this line, the difference between these cell sizes must not be so bad for the Western honeybee as it is for the other two, because they don't need as many like correcting cells to fix it, whereas they need a lot. So therefore, A looks pretty good. Like A is establishing that difference we see in the data between the Western honeybee and the other 2 species and accounts for that difference given the setup here, given why they would have these different cells in the first place. So A is looking really good. But let's check the rest. Both the Western honeybee and the black dwarf honeybee probably reserve 8-sided cells for drone eggs, while the dwarf honeybee likely deposits drone eggs in 7-sided cells. I don't know where we would even begin to try to support something like this. Like, first off, they are, for some reason, drawing a distinction between, or a commonality between the black dwarf and the Western and their 8-sided cells, when black dwarf doesn't use any 8-sided cells, and Western honeybee does a little bit. But like, the black dwarf doesn't have any, so why would it say it reserves its 8-sided cells for drone eggs? They don't have any. I don't know. We just don't know if they do. There's just no basis for this. And also, you know, the dwarf honeybee, yeah, it's got a lot of 7-sided cells, especially compared to the Western, but the black dwarf has more. So I just don't know where this distinction is coming from, nor does the text talk about the kinds of eggs that are put into these different sized cells. Like, we don't know anything about that. Let's not imagine what's possible. Let's just stick with what's in the text and what's in the figure. So B is out. C, the Western honeybee probably relies on many more geometrical shapes when constructing cells than either the dwarf or the black dwarf. I mean, just based on the comparison of these two, it's like they look to be the same number. Like, it uses fewer overall, but in terms of the types of shapes, it's the same as the dwarf. So again, a distinction here that I just don't think makes sense. It doesn't show that there's more shapes being used by this. In fact, it's probably the same number of shapes, just there's more of them being used here overall than here, which is the distinction we see in A. So C is just not true based on the figure. D, the percentage of hexagonal cells is probably slightly lower in the hives of the Western than in the hives of the dwarf honeybee and black. I mean, this almost seems to be the opposite of what we want, right? Like, there aren't that many of the non-hexagonals in the Western. And so that means there must be way more hexagonals proportionally than there are for these two, because they've got a lot more of these random sizes. So like D is just the opposite of what the figure is showing us. There's actually not that many non-hexagonal, which means proportionally they have more hexagonal cells compared to the other two species. So best answer here is indeed choice A.